We have a grouped frequency table and we're trying to see if a normal distribution will fit this. So the first part says, explain why the normal distribution might be a reasonable model for this distribution. Well, if we draw a little sketch of a normal distribution, this is what it looks like. And some features are that it is symmetrical about the mean. And this set of data is also very symmetrical. So that would be one thing you could say, it is symmetrical. Now, I think in the mark scheme it says it expects two things, so I'm not sure you'd get 1 mark for that. So let's add some more. Okay, another thing is that a normal distribution tails off, it goes to 0, and you can see that happens here. So that would be another good answer. It tails off either end, or it goes to 0, both ends or either end. And that would definitely be enough. Another thing you could say is that you definitely have the highest number around the mean, like in the middle, which you can see from here. Okay, so Gardner models a distribution with this normal distribution here. So that's a mean of 47.5. We're not being asked to check that, we're just being given it. And a variance of 10 squared, so a standard deviation of 10. Find the number of plums that this model would predict to have masses in the following two ranges. Note that the number of plums is 100, so we're going to get a probability, and we're going to times that by 100. Let's do that. So we just got to use a calculator, 7, normal CD, and we're looking between 35 and 45. With a standard deviation of 10 and a mean of 47.5. So 0.2956 and then we need to times that by 100. So we're going to get about 30. 29.6, I'm rounding it to the nearest number of plums. For m less than 25, very similar. This time my lower limit's just going to be a large negative number, my upper limit's going to be 25. And I get a very small number, 0.0122, which I need to times by 100, and that's going to be roughly 1 plum. So comment on the suitability of this. Well, for 35 to 45, we had 29, and that's very close to 30. And for m less than 25, it was 0. We've got 1. Our model answers are very close to the actual answers. So it seems suitable. We don't know for sure, but that's pretty good. I'd say it's very good. The market gardener plans to use the model to predict the distribution of the masses of next year crops. Comment on this plan. Okay, there's numerous answers you could write here, but you can't. One example is that the weather may be different next year. What if there is really cold weather? We don't know for sure if it will be accurate. So just a sensible reason, basically, to say that it might not be the same. I don't know if you get the mark if you said it could be a good prediction, because it's not a terrible idea to do that. If you were to say, oh, what if I double the amount of plums I'm going to grow? What will happen then? But just be aware that there could be problems with that. The weather may be different, so the model may no longer be suitable.